Hi everyone. I haven't made a video for about 2 months, partly because I have a new job, so I don't have as much time to code outside of work. However, I have been working on my own set of personal C libraries for fun, and I thought they'd be worth presenting. The particular milestone that I think is interesting and why I made this video is I just finished a JSON parser in C and just like JSON utility functions. So I hope you find this video interesting. Let's get into it. Okay, so here's my terminal window, and other than a terminal, I have Vim open where we're going to be doing some code editing. How we're going to organize this. Here is the top level of my Git repository. It's called chlibs. You could find it on my GitHub. Currently, I'm in a vlog branch, which I'll probably delete. It's just temporary. And there are two internal libraries right now. There is chutil and chjson. If we look into chutil, you'd see what maybe we'd expect. There are implementations of just the generic data structures you would want to use: a list, a linked list, array list, heap, map, string, so on. I'll probably add more as this project kind of matures. If we look into the chjson include directory, we see there are less headers and they're also a little less descriptive. Parser, we assume does some parsing. JSON-H and JSON helpers. Okay, it does something with JSON. So why don't we go into the JSON header file and we could look at what we're working with. So I'm not going to go too far into the code just yet because I want to demo it, because that's maybe the more interesting part to watch. So just really quick, there are 6 JSON types if you're unfamiliar with JSON. They're all very self-explanatory except for maybe object, which is really a map which maps strings to more JSON objects. Again, all of the composite types hold JSON objects themselves. I guess that's what makes them composite. So a list and an object, they hold JSON types. Again, I decided to do this all in pure C, so there are many places where I use dynamic dispatch, which would be a lot easier to do in a language like C++. I know this. That was not the point of this project, so don't roast me too hard. I know there are a lot of things I'm doing that are built into C++ that I kind of almost need to hack together here in C. So the main thing right here is that if you have a JSON type, or if you have a JSON T structure, under the hood, it holds what type it is, and it holds a union of whichever corresponding value you want. So we have our hash map, we have a list, a string. These underlying concrete types are implemented in the chutil library I hinted at earlier. The only other thing I'll say before we start coding is that the destructor, where is it? Here we go. I have a nice long note. The destructor assumes that your JSON object owns all of its parts. So in other languages like Java, where there's garbage collection, or in C++, where you can use maybe smart pointers, where you can devise smart ways of having one piece of data be owned by many, that is not the case here. I wanted to make this easy to implement for now, so we assume that your JSON object always owns all of its parts. If you have an object that maps strings to lists, and you delete the object, all of the lists and all of the strings, they will all be deleted. Everything. So just keep that in mind if you ever use this, and that'll explain some of the things I do when I'm coding this. Okay. With that said, we can actually get into the coding part. Okay. So for the demo, I'm going to hijack the main function that I was using for testing. I was using this testing framework called Unity. More on that another time. Anyway, I'm just going to put all of our example code here in this main function. So just starting out, I wrote very basic. So I make a new JSON number. I turn it to a string. I print out the string. I delete the string. I delete the JSON. So let's just get this running here. I already built this, so I can just run it. We get 3.14. Pretty easy. But obviously, numbers are not really the sole point of JSON. It'd be cooler if we had some sort of composite data. So why don't we use one of the constructors which is available to us. So let's try making a list of numbers now. So we can have new JSON list from elements. This macro is pretty helpful, as well as new JSON object from key value pairs. These are kind of nice for creating JSON in C. So let's try this out. New JSON list from elements. This expects at least one element. If you just have an empty list, you can do new JSON list. That'll give you an empty list. So now let's just fill this with numbers. New JSON number 5. New JSON number 6. And this is JSON, so I guess we don't need to just use numbers. We could use new JSON Boolean true. And we could even throw in a null value if we wanted to. New JSON null. So let's see what happens if we print this list out now. Oop. No. Look at that. This is what we'd expect. Valid JSON, 5, 6, true, null. Order is the order we gave it. For a list, order matters, obviously, so things are looking good here. But obviously, this is still pretty simple. We could nest things. I thought it'd be cool to kind of have an example where we create a JSON object and then maybe modify its values and then print it out after the values are modified. So now, instead of having our elements just be kind of like random values here, maybe what we could do is have new JSON object from KVPs. So we're going to create a list of objects now. The way this constructor works for new JSON object, KVPs, is it's going to alternate. So the first value is going to be a string pointer. The next value is going to be a pointer to JSON. Then a string pointer, then JSON, and so on until you stop. So we'll say I don't know. We'll have new string from literal, and we'll say name. New JSON string from literal, we'll say Dale. So the idea here is that, well, one quick thing to note here is that there is a difference between strings and JSON strings. A JSON string kind of encapsulates the string type. So because we know the key needs to be a string, we just use new string from literal. Okay, the value has to be a JSON type, so we have to do new JSON string. Okay, so there is a difference. If I were to do new JSON string as the key, that would cause problems. So anyway, we're gonna have this, and let's say we have new string from literal age. And we'll do new JSON number. We'll say Dale is 25. All right, now let's throw in some other people here. So we can copy and paste this kind of template a few times. Oh no, that's not what I wanted to do. So let's make this 26. Actually, what am I saying? Let's make this like 35. And we'll make the name Brad. Brad is nearing his 40s, nearing the end. And we're going to make this name, I don't know, Matt. And we'll say Matt is 50. You know, he's on the downward slope. Anyway, so we have our 3 people. And let's just print this out again as a string just to make sure that everything's working properly. All right, things are looking good. This looks like a valid JSON object to me. We have the names and the ages. Note that even though we defined the name first, age comes first. That's kind of random. I mean, if we added more keys, I'm sure the order would be different. The order of keys and values in the object is not important. So anyway, that's an aside. Okay. So now let's say we have our JSON, our list of objects, and we actually want to do something with it. We want to change it, right? Let's say this data is maybe from some old database that was last updated 5 years ago. So we want to go through every person and we want to add 5 to their age because 5 years have passed, right? So is there an easy way to do that? So, you know, easy is relative. If this were Python or JavaScript, we could do this. What am I doing? We'll keep this in here. If this were Python or JavaScript, we could do this in a nice syntactically pretty way. Again, C is a static language, so we kind of have to do some tricks. So let's see. I mean, not really tricks. It's how the library is built, but it's not really, you know, it's a little awkward, I'll be honest. So again, so under our JSON object, we know is a list. That's the parent type. It's a list, right? That's the concrete type under the hood. So we're going to do list t star L, and we're going to do JSON as list JSON. If our object were not a list, this would return null. We know it's a list. We're not going to do any error checking for now. Now what we want to do is we want to iterate over the list's cells. And for each cell, we're going to have a JSON pointer, and we're going to modify that accordingly. So let's iterate. We're going to have JSON t star star val pointer. And we're going to do L reset iterator. L. And we're going to do while val pointer equals L next L. Am I missing a... All right, so one thing to note, our list, the underlying type is an array list, and the cells inside the array list, the size is variable. When you create an array list, you could say, I want each cell to be 50 bytes or 10 bytes, right? So when you use the array list, when you get a cell, you actually get a pointer to the beginning of where the cell starts. This way, you don't need to copy a big chunk of data if the size is, you know, is pretty big. Also, it makes it easy to modify cells inside, you know, or modify the values inside the cells themselves. Anyway, that's not really the point. The point is here, the list holds JSON pointers, and we get a pointer to each cell. So the cell holds an address, and we get an address of the cell. So our address, its type, is a pointer to a JSON pointer. A little confusing, I know, but it actually is pretty nice. It makes things easy to use. So anyway, what we want now is our JSON t, I'll say person, star person. It's going to equal star val pointer. Okay, now we have our person, and what we want, let's think about this. We want their age, so we're going to do JSON t star age pointer, and actually I'll call this age JSON, and you're going to see why. And we're going to do JSON lookup C string, so person and we're going to look up the age field. Now, we know that our age is not an arbitrary type, it's a number. So what we can do is we can do double star age pointer equals JSON as number age JSON. Finally, we can actually do the doubling, so we can do star age pointer. It's going to equal 2 times star age pointer. Now, moment of truth, did this actually work? Age-old question. Let's run make run tests. So again, let's look. So above we have 25, 35, 50. Oh wait, what am I doing? I'm sorry. This shouldn't be times 2. That's too old. We want to add 5. That was the point. Sorry. Almost just killed mad. Anyway, let's do make run tests. Look at that. So we have the same objects, or we have the same list, same structure, but now our ages are increased by 5. Nice. And let's say now we wanted to, let's think about this. How could we juice this up a little bit? What if, for now, just as an example, okay, don't get too worried here. What we're going to do is we're going to run the exact same thing, but now what we're going to do is we're going to take the results and we are going to append them to a new file, and it's going to be desktop, and I'll call it in.json. You'll see why I call it in a second. So let's run it, and now let's vim our desktop in JSON. All right, and we can delete the command we ran. All right, so now we have the same data, but now it's in a JSON file. Let's see if we can make use of this, right? Because maybe instead of getting this kind of dynamic definition of the JSON, we actually get a file which stores the old values that we want to update, right? So what we can do is we can use this thing called an input stream, which can be derived either from a string if you want to read the characters of a string, or from a file if you want to read the characters from a file, or you could extend it to, you know, read characters from whatever you want. So let's just do that. So in stream star is, it's going to equal new in stream from file. Now, lucky for me, I planned ahead, and I have the absolute path of our file right here. I know, very sneaky. And what we're going to do, we're going to put this right in here. Later, we're going to delete this in stream is. Finally, we're going to have JSON t star JSON, and we're going to do parser state t ps equals JSON from in-stream is and JSON. So this does not return the object, it returns a state, which is used for error checking. So we could say if ps doesn't equal parser success, we are going to, what are we going to do? We're going to print out, we are going to print out bad parse. No. And we are going to return 1 right away. We can put this delete up here, why not? So what this does, again, it's going to parse our JSON. It's going to put the resulting object into this field right here. And now we can take this and we can delete it. So now let's see if this works. So again, if we vim in here, we have 30, 40, 55. So we should have 35, 45, 60. So now it's been another 5 years. So time's really flying here. Run tests. Uh-oh. What did I do wrong? Oh no, I didn't do anything wrong. I'm just tired. That's right, these are the right values. Awesome. Now we could pipe these results to a new file like we did when we created it. Another thing we could do also, which is a little bit easier, is we can have what's called an outstream, which is kind of the opposite of an instream. Outstream t star os equals new outstream to file. And we are going to use... Also, I have no idea why I copied and pasted this up here. This is a macro. This should be in file path. Out file path, and we're going to do it in write mode. And let's not forget to delete our outstream OS. Now we can take out all this string garbage, and we can do JSON to stream, JSON OS, and we're going to have indents. So now, if all works, if all goes according to plan, we should have a new file. What's it called? A new file called out.json, which contains our new ages, the updated ones. So let's make run tests. Okay, now let's vim desktop out.json. Look at that. We got our new 5-year-older ages, and it's in a file. Perfect. So anyway, that's about it for the demo. I could go into the implementation, but you could do that yourself if you're really interested. It's not too complex. But thank you for watching if you made it this far. The code is all on GitHub in my chlibs repo. It gives you all the instructions on how to build it, how to download dependencies, how to install it on your computer, and so on. So anyway, thanks for watching, and hopefully I'll have a new video soon.